Hello and welcome to Core 4 Revision with Mr. Quinn. Today we will be working through the June 2010 MEI Core 4 paper. I will be giving hints followed by work solutions. I would encourage you though to attempt the questions after listening to the hints, and only after this should you refer to the work solutions. Question 8. Parametric equations combined with compound angle formulae. For part 1 we're trying the values of the parameter in this case being theta at point A and point B. To do this, think about what the y value is at A. Then, for part B, think about what a cosine graph does. What is the range of a cosine graph, and what is the range of 4 cos theta then? Because we know that B is a minimum point. To try and find the ratio, you will need to look at the values of the parameter theta at A and B, filling these back into x and y. This will allow you to find the distance OA and the distance AC. For part 2, to find dy dx in terms of theta, we need to differentiate x with respect to theta and y with respect to theta. Then use the chain rule. To find the gradient of the track at A, we can fill in the value of our parameter. For part 3, to show that when the gradient of the tract is 1 satisfies this equation, will we know dy dx from part 2, set this equal to 1, and then rearrange. For part 4, we need to rewrite cos theta minus 4 sin theta in terms of r cos theta plus alpha. Have a look at your compound angle formula. Then try and solve. Now hit pause and you give it a go. Work solutions to part 1. In part 1, to try and find the value of the parameter at A, well, at A we know that y is equal to 0 as it lies on the x-axis. So we can set y to be 0. This therefore gives 4 cos theta to be equal to 0, which means cos theta is equal to 0, meaning that theta is equal to pi over 2. At B, well, we know at B that it is a minimum point. We also know that the y value is equal to 4 cos theta. Now a cosine graph goes between 1 and minus 1. However, this graph has been stretched parallel to the y-axis of scale factor 4. So this actually goes between 4 and minus 4. So at this point, we know that y is equal to minus 4. This therefore gives us 4 cos theta equal to minus 4. Hence cos theta is equal to minus 1, giving theta to be equal to pi. Now we need to find the ratio of OA to AC. To do this, we need to find the x value at A, as this gives us the distance OA. We need to find the x value at C, which is the same as the x value of B. This then allows us to find OA, and to find AC, well, that's equal to OC minus OA. Firstly, finding OA. Well, at A, theta is equal to pi over 2. So 2 theta minus sine theta gives us 2 times pi over 2 minus sine of pi over 2. This simplifies to pi minus 1. Now, AC, well, let's find the x-coordinate of C. At C, theta is equal to pi. So this gives us, to find the x-coordinate, 2 times pi minus sine of pi. But that gives us the entire distance away. We now need to subtract away from that. Now, as can be seen, simplifying this side gives us 2 pi, take away pi, leaving us with pi. Minus sine pi, well, sine pi is equal to 0, so we have 2 pi take away 0, which is just 2 pi, then subtract pi, then plus 1. Hence, we have the ratio as desired. For part 2, we want to find dy dx in terms of theta, and then find the gradient of the track at A. As you can see, we know x is equal to 2 theta minus sine theta, so differentiating with respect to theta gives us 2 minus cos theta. Differentiating y with respect to theta gives us minus 4 sine theta. Now we're going to use the chain rule. We want dy dx. Well, this is equal to dy d theta times d theta dx. We already have dy d theta, but we have dx d theta instead of d theta dx. This is relatively straightforward to simplify. So we want d theta dx. Flipping it over, we end up with 1 over 2 minus cos theta. Now we can find dy dx to be equal to minus 4 sine theta over 2 minus cos theta. Now, to find the gradient at A, well, at A, theta is equal to pi over 2. This therefore gives the gradient of dy dx equal to minus 4 sine pi over 2 all over 2 minus cos of pi over 2. So therefore the gradient, typing this into your calculator, or maybe just knowing it, because sine of pi over 2, well, that's 1, and cos of pi over 2, well, that's 0. So we end up with minus 4 over 2, which gives us a gradient of minus 2. For part 3, to show that when the gradient of the track is 1, in other words, when dy dx is 1, theta satisfies this equation. Well, let's have a look. So, if the gradient is 1, dy dx is 1. And from before, we know that dy dx is equal to minus 4 sine theta over 2 minus cos theta. Simplifying gives, or multiplying through by the denominator, 2 minus cos theta is equal to minus 4 sine theta. Now, just multiply through by minus 1. And we get the answer we're looking for. Now, we want to express cos theta minus 4 sine theta in the form or cos theta plus alpha. To do this, we need to use the compound angle formula. You can find these in your formula booklet. Using the compound angle formula, we can expand r cos theta plus alpha to give r cos theta cos alpha minus r sin theta sin alpha. Now, here we have 1 cos theta, but here we have r cos alpha cos theta. This gives us r cos alpha being equal to 1. Doing the same thing here, we have 4 sin theta, and here we have r sin alpha sin theta. This then gives us r sin alpha being equal to 4. Simplifying this gives cos alpha is equal to 1 over r, sin alpha being equal to 4 over r. Now we can look at this in the form of a right angled triangle, choosing one of the angles for alpha. Cos is adjacent over hypotenuse. Sine is opposite over hypotenuse. Now, using Pythagoras, r is equal to the square root of 4 squared plus 1 squared. So r is equal to the square root of 17. Taking the tan of alpha to be equal to 4 over 1, this gives us alpha to be equal to 1.326 radians. Now we can rewrite cos theta minus 4 sin theta in the form root 17 cos theta plus 1.326 radians. Now, to try and solve cos theta minus 4 sin theta being equal to 2, we can instead use the square root of 17. Cos theta plus 1.326 radians is equal to 2. Simplifying this gives cos theta is equal to 2 over the square root of 17. Taking the inverse cosine of this leaves us with theta plus 1.326 radians being equal to 1.064 radians. Remember to have your calculator in radian mode. Then, to find the next one, 2 pi subtract 1.064 gives us 5.219. Now at this point, you might notice we're about to subtract 1.326. Well, 1.326 is larger than 1.064, which means this one will not lie in the correct range. So we need to find another answer. To do this, we will add on 2 pi onto 1.064. This gives us 7.348. Now, subtracting 1.326 from all of these gives us minus 0.262, 3.89 and 6.02, all in radians. However, we don't want to include that one because it's not in the correct range, leaving us with 2 valid answers. This concludes the Core 4 June 2010 paper.